Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 6.6 entitled The Law of Cosines. And today we're going to review the law of cosines, which you've seen possibly in geometry, but definitely in Algebra 2. And then we're going to relate it back to the law of sines in the ambiguous case. And then we're going to talk about two applications. One is for navigation, and one is another way that you can find the area of a triangle. Okay, now when we're dealing with the law of sines, you can only use the law of sines when you have, let me write this up here. Use the law of sines when you have an angle side angle set up in your triangle, or when you have a side side angle set up. And remember, the side side angle, that was the ambiguous case. Now for law of cosines, you're going to have the other two setups where you know all three sides, which is side, 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 or where you know two sides and an angle, a side, angle, side. So when we have those two cases, that's when we're going to do the law of cosines. And the law of cosines is, it's three formulas basically, and these formulas can help you find any angle or any side of a triangle. But this is when you do not have a side and the angle that's opposite from it. Okay? Or maybe I should write that a little bit better. Let's say that when you don't have an angle and an opposite side, I guess that's how we've been phrasing it. There we go. So if you do not have an angle and then a side that's directly across from it, you can't set up law of sines because that's the key factor that you need for law of sines. So when you don't have that, then you use the law of cosines. Now notice that you can use any of these three formulas. We're just going to use one at a time. But notice that what you're solving for is going to be a side measurement. And then what you're going to be using here, this is side A, so you're going to be using angle A. And then you also have the B's and the C's that get filled in inside of it. So angle or side B is outside here on the left side of the equation, and angle B is on the right side of the equation. Side C is on the left side, angle C is on the right side. Okay, so that's one way to help you remember how these equations are set up. And then if you have side C and angle C, the variables in the middle then are going to be the A's and the B's. And it's always the sides squared, and then you add those up, and then you subtract 2 times the sides times the cosine of the angle. So it's the same pattern when you're setting these up. Okay, so it's side squared plus side squared minus 2 times side times cosine of the angle. Now, which of these you use depends on what information you're given in your triangle. Okay, so let's take a look at an example here. We have a side, side, side scenario. As you can see, it's in the title here, and then it's in the picture. We've got all three sides labeled. And here in the problem, it says the sides of the triangle are 5 and 8 and 12. Find the angles of the triangle. So we're still solving for all the missing pieces of information. It just so happens that the missing pieces of information are going to be the angles. Now, when you're dealing with this situation, let me put this up here. You want to start with the largest angle. Okay, a lot of times students aren't sure where to start this problem and they just kind of jump right in, but that can create issues later on. Okay, so good rule is to start with the largest angle. Now, if you're looking at these measurements and you're looking at this picture and you're thinking, how do I know which is the largest angle? Hopefully you remember that large angles are across from large sides, and medium angles are across from medium sides, and small angles are across from small sides. So if I'm going to start this problem, I have to find angle C first because that's going to be my largest angle. And I can't set up law of sines because I don't have an angle and a side that are across from each other. So I have to use law of cosines. Now I'm going to be finding angle C, so that means I'm going to be using that equation that starts with c squared equals. Okay, so my c squared is the 12. 12 squared equals, and then it's your other two sides. Doesn't matter what order you put them in, but we would want 5 squared plus 8 squared minus 2 times 5 times 8 times the cosine of the angle, cosine of C. Okay, now this is where students make a lot of calculation mistakes. We need to figure out what 12 squared is, obviously. That's 144. 5 squared is going to be 25. 8 squared is going to be 64. Then we have to figure out what 2 times 5 times 8 is. Okay? That is the number that's going to be in front of the cosine of C. And that is eventually what we're going to have to divide by to get cosine of C isolated. So that's going to be an 80 cosine C. Now, students often forget that that 80 has to stay with the cosine C for now. So as I try to solve for the cosine of C, I'm going to take the 144 minus the 25 and minus the 64. But I'm still going to leave the negative 80 cosine of C. I can't add the 80 over because it's being multiplied by the cosine of C. So don't forget your order of operations here. Okay? But once I take 144 and subtract 25 and subtract 50 or 64, I get 55. And then I have negative 80 cosine C. Now I can divide by that negative 80 and get a decimal. So that's going to be negative 0.6875. Okay, so time and time again, I see students that will take the 144, subtract the 25, subtract the 64, and add the 80 over. And that's just incomplete mathematical, incorrect calculations. Okay, so make sure you're paying attention here when you're solving these. Now we're going to do cosine to the negative 1 of this decimal. Don't worry about it being negative. Your calculator can handle that. And you'll get angle C to be 133 degrees. Make sure your calculator's in degree mode. We still want to be in degree mode. Okay? So we have angle C. And now I have an angle and a side that's across from it. So now to finish this problem, I can do the law of sines. So let me do that in another color here. Maybe I won't do it in another color. Okay, I won't do it in another color. Let me label it here, step 2. Okay? So since I know that angle C is 133, I can set up sine 133 over 12 equals. Now I need to do the next biggest angle. Okay, so I'm going to start with the largest angle, and then I'm going to go the medium one, and then the small one. So I need sine B over B, because 8 is bigger than 5. So sine angle B is going to be my next biggest angle. So then I'll cross multiply and divide. So sine of B would be 8 times the sine of 133 divided by 12. And that's going to get me 0.4876. And then when I do second sine of that value, B should be 29 degrees. And you can round to the nearest whole degree for these. Pay attention to what your book says. Your book might want you to round it to tenths or hundredths. So pay attention in the directions, but if you want to round it to nearest angle, that's fine. Okay, and then my last thing to do then for step 3 would be to find my angle A. So the measure of angle A then would be 180 minus the 133 plus the 29, and I should get 18 degrees. So law of cosines is really just what we use for the very first step. After that, it's law of sines, which is just a proportion where you cross multiply and divide. Okay? Your book, if you look at this type of an example in your book is going to use law of cosines 3 times. They're going to do the law of cosines to find angle C, then they're going to do law of cosines to find angle B, then they're going to do law of cosines to find angle A. Now, if you want to do that much work, you certainly can. You'll still get the same correct answers. But I think starting with the law of cosines and then doing the faster method of your proportion and then subtracting from 180, that's definitely a lot faster than doing cosines 3 times. Okay, so let's take a look at another example then. This is going to be the other case for law of cosines where we have a side angle side. Let me see if the computer will let me change colors now. No, it will. Okay, so we're going to solve the triangle that has angle A, 29 degrees, side B, 73, and side C, 50. Now this time we don't have a picture, so if you want to draw a triangle and label it ABC. Doesn't have to be drawn to scale. We just need to put that information in some kind of visual picture for us. Okay, but notice we've got a side and an angle and a side. Okay, so I can't set up law of sines because I don't have a side A across from angle A. So I have to do law of cosines to start this. Now, if I had side A, that would be super convenient because then I could use law of sines to finish off this problem. So, for my first step, I'm going to use the law of cosines to find side A. Then I'll be able to do the law of sines to find the other angles, B and C. So I'm going to use that equation that starts with a squared. Okay, and then I'll have 73 squared plus 50 squared minus 2 times 73 times 50 times the cosine of 29. Now this problem is way more straightforward here because I'm not finding the angle, I'm finding the side. So basically I just have to simplify this whole right side of my equation, take the square root, and I'll have my measurement for A. Okay, so you're going to get some really big numbers. I can write them in here if you'd like. 73 squared is going to be 5329. 50 squared is 2500. And then you could do this a couple different ways. You could do 2 times 73 times 50, which is 7300, and then the cosine of 29. Or you could take 2 times 73 times 50 times the cosine of 29. Eventually you're going to have to do that anyway. You're going to have to multiply those together. Okay? So you'll need the 5329 and the 2500 minus, see, I believe you get 6384.7239. And then when you add and subtract those all together, you'll get 1444.2761. Now when you're dealing with the cosine here, round it to 4 decimal places so that you're more accurate, okay? And then we're going to have to take the square root of that value, okay? Because this is still what a squared is equal to. So then to find a, I have to take the square root of that number, the 1444.2761. And that comes out to be about 38. Okay? So now that I know that A is 38, now I can go through and I can find angle B and angle C. Now remember, I have to start with the largest angle. Okay, now I know angle A is 29. That may or may not be my largest angle in the whole triangle, but I need to find which is going to be largest next between B and C. So of my remaining angles that I have to find, which is going to be the largest of those? Okay, so again, angle B is across from a side that's 73. Angle C is across from a side that's 50. 73 is bigger than 50, so I'm going to find angle B next. That's going to be my second step. Okay, so to find angle B, I can do law of sines now because I know what side A is. So I can do sine of 29 over 38 equals sine of B over 73. So then I cross multiply and divide. So I'll have 73 times the sine of 29 all over 38. And that's going to get me about 0.9313 if I round to 4 places. Now, that value, remember, think back to our law of sines now with our ambiguous case, that value is less than 1. So that means that I have 2 possibilities here. So if I do the second sine of that number in the calculator, I'm going to get B is 69 degrees. And then I also have to do 180 minus 69. And that's going to get me 111 degrees. Now, I'm not going to have 2 cases here. I'm not going to have 2 triangles. Okay, I'm going to have 1 triangle. And how I figure out which of these is correct is which of these is going to make more sense for this problem. Okay, angle B is supposed to be across from a really large side. So it's the largest side in my triangle even. I've got a 73 side, I've got a 50 side, and then A was a 38 side. So does it make more sense for that 73 side length to be across from a 69 or a 111 degree angle? It's going to be across from the 111 degree angle. Okay? So here you're just kind of using a little bit of reasoning to think through this and rule out which angle works and which angle doesn't. Okay? Then for my last step, I'll put it in over here. I just have to find the measure of angle C. So that's just going to be 180 minus the 29 plus the 111 that we just found. And that's going to be 40 degrees then. Okay. So you've got one application for each where you're dealing with the side, 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 or the side angle side for the law of cosines. Okay, so now let's take a look at 2 application problems here. This first one is with navigation, and this is kind of cool, okay? In navigation, a direction is often given as a bearing, and that is when they take an acute angle measure from due north or due south. You could also do it from due east or due west too, but it's really from due north or due south, okay? And so basically you're measuring how far away you are from due north. So from that 90 degree angle, or due south, that 270 degree angle, okay? So here, if they say the bearing north 30 degrees east, that's going to mean that you started out going due north and then you went east or to the right 30 degrees. So you're 30 degrees away from due north, but you're heading in the direction that is east. Okay? So let's take a look at an example here and see if we can figure out our bearing and our navigation. So a pilot sets out from an airport and heads in the direction north 20 degrees east. So he was going straight north and then he went 20 degrees in the direction of east. Okay? and he's flying 200 miles per hour. After 1 hour, he makes a course correction and heads in the direction of north 40 degrees east. Half an hour after that, engine trouble forces him to make an emergency landing. So we need to find the distance between the airport and his final landing point, and then find the bearing from the airport to his final landing point. Okay, so he did kind of a course direction change here. Okay, he was starting off flying north 20 degrees east. So there's not a whole lot of room here. Let me squeeze it in here. So he was going north and then he went 20 degrees east. So that's the 20 degrees in there. Okay. And then after an hour, he makes a course correction and heads in the direction north 40 degrees east. Okay. So, okay. So after an hour, he makes a course correction and heads in the direction north 40 degrees east. So then from here, let's look at the next slide because it has a little bit better picture here for A. Okay, so he has started off at his point. He's flown north 20 degrees east, so he's flown at that navigation direction. Okay, and he was going 200 miles per hour, and he was doing this for 1 hour, so that's a distance of 200 miles. Okay, then after that hour, he makes a course correction. So you got to think that there's like a little another axis here. And this time he goes north 40 degrees east. So he's going to turn and go this way now. So here's your 40-degree angle. And he goes this far for a half hour before he has engine trouble. So if he was flying 200 miles per hour, in a half hour he'd go 100 miles. So that's the distance there, is 100. Okay? And we have to find the distance between the airport and his final landing spot. So we have to find this side here, which would be little b. That's what we have to find. Okay? But we also have to find the angle. Okay, we know this outside angle is 20 and this outside angle is 40. I need an angle inside my triangle. And we have enough information where we can find angle B. Okay? I can't find angle A because I know that this is 20. I don't know what angle A is, and I don't know what this other exterior angle distance is here. So I don't have enough information to find angle A. I can't find angle C. I don't have enough information for that either for the same reason. I know, but for B, I do know that this is 40 degrees. And if I drew in my little X and Y axis here, okay, this would be a right angle. So this would be 90 minus 40 gets me 50. I know that this little part right here, that's going to be 90. So that's going to be 140 altogether. And then if you have this little axis here, this little y-axis, and this one here, going to drop it down, they're going to be parallel. They're parallel lines. And then this is your transversal that goes across it. So you got to think back to your geometry days here. When you have parallel lines that are cut with a transversal, you get alternate interior angles that are going to be congruent. So this little sliver in here is going to be 20 because it's going to be congruent to this 20-degree angle out here. So that 90 plus the 50 plus the 20, that's going to add up to 160 degrees. So that's the measurement for angle B. Okay, so now I have angle B, I have side B that I'm trying to find, and I know side C, this would 200 would technically be side C, and I know side A, which is technically 100. So I have a side angle side scenario where I can use law of cosines. Okay, so I'm going to be finding side B here, so I'm going to use that equation where it's b squared. So my side is 100, and my other side was 200. So I'll have 100 squared plus 200 squared minus 2 times 100 times 200 times the cosine of my angle, which is 160 we found. Okay. So now if you do 100 squared and 200 squared and you add them up, you get 50,000. And then 2 times 100 times 200, that's 40,000. And remember, that's still multiplied by the cosine of 160. Okay? So then you have to take the 50,000 and you have to multiply the 40,000 and the cosine of 160. Okay, so when you do that, you get a negative value. So minus a negative is plus a positive. 37,587.70. And then you add in your extra 50 and you get 87,587.70. But now I still have to take the square root of that to get b. So 87587.70, take the square root of that, you get 295.95, and that would be miles. Okay, so he's almost 300 miles away from the airport. Whew. Okay, so finding the distance was okay there. We were able to use law of cosines. Now it says find the bearing from the airport to his final landing point. Okay, so from the airport to his final landing point. So they want this whole angle right in there. Okay, they want his bearing. So that means I've got to find angle A, basically. Okay, now don't know angle A, but I do know side A. And I know angle B, we said that that was 160, and I just found side B to be 295.95. So I can use the law of sines here. Okay, so if I'm going to find angle A, basically, is what we're doing, I'm going to take the sine of A over side A, which was 100, set it equal to sine of B, which was 160, over 295.95, side B. Okay, and then I'll cross multiply and divide. So sine of A is going to be 100 times the sine of 60 divided by 295.95. Let's see, that decimal then, when I take the second sine of that, I'll get about 6.64 if I round. Okay, so that's angle A, but now it says to find his bearing. Okay, so that means he was going straight north and then he went that 20 degrees plus another 6.64. So you have to add that in, 6.64. So we get 26.64. So his bearing then would be north 26.64 degrees east. Now read the directions in the book to know if they want you to round it to tenths or to hundredths, or if they want you to round it to the nearest degree. If you did round this, it would be 7 degrees. So then you'd have north 27 degrees east. Okay, so pay attention to the directions there. Okay. It definitely helps to draw a picture. And these pictures, even for the bearing ones, are going to have some kind of triangle in there. And you might have to think back to some type of geometry skills there where we had to do the parallel lines and the transversal and the alternate interior angles. But once you get that part taken care of, it should relate to law of cosines or law of sines somehow. Okay, last thing then is an application for the area of a triangle, and this deals with law of cosines, and it's a pretty quick, easy explanation here. It says an interesting application for the law of cosines involves a formula finding the area of a triangle from the lengths of its three sides. So here you don't need any of the angles, you just need the three sides. And this formula that they derive it in your book on page 479. If you really want to look at the proof for where this formula comes from, it's there. But what it does, it says that the area of the triangle is this. Okay, and A and B and C, those are going to be your side lengths. Okay, and then they also have S. S is called the semi-perimeter because it takes the perimeter, A and B and C, adds them up and divides them by 2. Okay, so you have your semi-perimeter times the semi-perimeter minus your first side times the semi-perimeter minus your second side times the semi-perimeter minus your third side. Okay, so the semi-perimeter is basically half your perimeter. So you're finding area and all you're using is perimeter in some way, shape, or form. Okay, so let's try this out. It's just a pretty cool, easy application. Okay, so here we have a businessman and he wishes to buy a triangle lot in a busy downtown location, and the lot frontages on 3 adjacent streets that are 125, 280, and 315 feet long. Find the area of the lot. Okay, if you're dealing with real estate, you got to know how much square footage you've got and how big your property is for taxes and costs of the real estate and all that good stuff. So first we need to find our perimeter. So we're going to add up 125 and 280 and 315, and that should give us 720. And then we need our semi-perimeter, so we need half of the 720, so that's 360. Okay, so now I'm basically just going to plug all that into my formula. I need my side lengths and then my semi-perimeter to plug it into the area formula. So it's the square root of, I need the semi-perimeter, and then I have to do the semi-perimeter minus the first side, then the semi-perimeter minus the second side, and the semi-perimeter minus the third side. So if you want me to simplify those numbers, I can. It's 360 times 235 times 80 times 45. So you can make sure you did those calculations correctly. If you multiply that all together, you get a huge number. That should be your number. And then when you take the square root of that, you're going to get 17,451.65. And it's going to be feet squared because it's area. So this is a cool formula because you don't need to worry about doing any trig. You don't need to do dropping in altitudes and making right triangles and doing law of sines and cosines or SOHCAHTOA. None of that. It's just perimeter and square roots and a little multiplying and adding. So it's just a cool application type problem that I wanted to show you. Okay, so the main focus of this homework then is going to be practicing the law of cosines. Those bearing problems can be a little tricky, so definitely take a look at the back of the book. Okay, the odd ones are in the back of the book. Sometimes seeing the answer for those can help you when you're figuring out how to draw the triangle and take your measurements. The evens are going to be worked out in the binder in the classroom, as well as the odds. And if you have any questions, come on in and see me before school.